I'm so excited that he found the time to come to attend to our event and come to share his brilliant thoughts, because I think that he is one of the most brilliant minds that I have met throughout my life. And well, his resume is also talking to about that brilliant mind that he has. So he is a former senior scientific advisor to the UK government's Committee on Safety of Medicines and chair of Forum and Food and Health of the Royal Society of Medicine. And currently is also fellow of the Institute of Food, Brain and Behaviour in Oxford. And what we just found out that he is nominated by the Global Summits Institute to be part of the top 100 doctors in the whole world. Maybe he will elaborate a little bit more. What does that mean? But I'm so honored to welcome our next speaker, our one and only, the father of pharmaconutrition, Dr. Paul Clayton.
Good afternoon, Margus. Can you see and hear me?
Yes, sir.
Good, I'm live. Okay, well, thank you for that introduction. I don't particularly want to elaborate on that top 100 doctors thing. I didn't even know about it until a few days ago. I had no idea, and I don't actually know what it means. So let's go straight to the science. I'm going to talk today about senolysis, which may seem a little foreign to many people, but it's a very important part of anti-aging medicine. Quite a new area and a very hot topic. Every single pharmaceutical company in the world is playing in this field right now because it offers the prospect of significantly extended life, not just adding years, but adding healthy years, because senolysis seems to be an important part of the way in which our tissues degenerate and run down as we get older, with an associated loss of function, loss of health. And if we can find a way of reversing that, we are attacking the aging process and reversing it in the most profound manner. So I think that that's a much more interesting topic. And what I'm going to do now, I'll share the screen and show you some slides which cover some of this. So I'm going to talk about spring cleaning, but not the spring cleaning that you're familiar with. With the other products that we have, the formulations in our small portfolio, what we're able to do is to stop many elements of the aging process already and ensure a better chance of achieving optimal health. And we do that by stopping inflammation, which we can do with balance oil. We can restore a healthy microbiome, which we do with ZinoBiotic. And we can treat and undo type B malnutrition with Extend. And that's a bit like the cleaning that you do every day or every week if you're not quite so house proud. But spring cleaning is what happens at the beginning of a new year when the sunlight starts to get stronger and you realize there's a few corners of the room that maybe you hadn't gotten to in your daily routine and you want to do something more intense. And that's what senolysis is all about. We developed a new tool to help with this deeper form of cleaning, if you like, and I'll talk about that in more detail. There's a parody of spring cleaning. That's what most people think of, but we're talking about a kind of an intensive cleaning system for your cells. This is called ZinoGene, and it contains two broad classes of actives, and one group of these actives is designed to remove senescent cells, and the other is designed to replace them. So having given you the basic outlines of what Geno is, let me go into it in a little bit more detail. As you can tell, the numbers on this clock are all running backwards. That's exactly what we're hoping to achieve with senolysis in general and with ZinoGene in particular. We've got to the point where a large part of the aging process is now quite well understood. There's not a single aging process. There's actually a whole lot of different aging processes which run together. And if you were to ask me, how can we stop or slow aging? I wouldn't be able to answer that question, really. But if you were to rephrase the question and say, well, out of the many subroutines that drive the aging process. Could we reverse or stop those? Actually, then I would change my position and say, yes, probably yes. We are now in a position where we can modify almost every single one of these. So let me quickly list the different types of subroutines that we now know are important in the aging of cells and tissues. And one of these is loss of proteostasis. And proteostasis is a rather complex term, but it describes the correct maintenance of the right types of functional proteins inside the cell. And if you're breaking down those proteins, these intracellular proteins, more quickly than you should, or if you're accumulating too many damaged proteins, that's really destructive for the cell and will eventually either make the cell senescent, which means it's senile, if you like, or it'll kill it. Autophagy is a process of intracellular housekeeping. It's to do with the maintenance of internal structures, the removal of damaged elements and the replacement by new ones. And we know that as we get older, that process, these twin processes of proteostasis and autophagy start to run down. But there's a lot of other things as well. Loss of telomeres, and you've probably heard about that. Telomeres, these are the bits on the ends of your chromosomes, which are really important when it comes to cell division. If you don't have telomeres, you can't divide your cells properly, which means you come to the end of your cell's useful life and there's nothing to replace them. But there's much more to it than that, because in these same cells, you're accumulating mitochondrial damage. Within the chromosomes, we're seeing changing patterns of DNA methylation. This is the science of epigenetics, which of your genes are active and which are silent. And that pattern changes with time. Various the histones which surround DNA, they also change with age as well. In some ways, that's not quite so well understood. You have something called the reduced expression of pre-mRNA splicing factors. This all takes place in a functional organ system inside each cell, which is called the spliceosome. Everything inside the cell is called a some of one sort or another. And this is where RNA that is first constructed is actually chopped up and reassembled. And it's done so in different ways, slightly different ways in different cells, which allows a relatively small amount of genetic information to code for a rather large number of proteins where they have different functions in different tissues. Growth factors such as BDNF, which you may have heard us talk about before, tend to reduce over time, so that impairs your body's ability to repair and restore certain tissues. We become less able to resist stresses of various kinds, and this is a group of alarm bells which are present in our tissues, in our cells. They're called alarmins. And they respond to heat stress, to osmotic stress, to microbial stress. And that's part of the way in which the body responds as a whole to the slings and arrows and accidents of a changing and demanding environment. And our ability to ring those alarm bells tends to decline with age. And then we get metabolic and endocrine sag, and that's a rather loose phrase, and it simply refers to the way in which you see a kind of metabolic degradation with age, and you get in many of the enzymes, hormonal systems, a rundown of the body's ability to produce the hormones that you need. And now I'm coming to one of the perhaps deepest elements of the aging process. You get an accumulation of senescent cells and insufficient stem cells. Now, senescent cells are cells that have come towards the end of their working life. Many cells, when they do this, they will engage something called the apoptotic cycle. So they do the equivalent of retiring to the library with a glass of whiskey and a pearl-handled revolver. They realize that they're no longer useful. They make an end to themselves. That's actually a very positive thing. Some cells don't quite do this properly, and they linger on. Instead of terminating themselves, they remain in place, and they're now using up valuable resources, but not making a contribution. And they're also starting to create local inflammatory changes. So this population of senescent cells makes an increasing contribution to the declining function of tissues, whichever tissues they are present in, whether it's the central nervous system or in muscle or in the liver or the kidney. It's a decline, a slow decline of functionality. And if we were still working properly, if our other repair systems were working properly, we might be able to get around this. But the other thing that happens as we get older is that we start running out of stem cells. These are the pluripotent cells that we store in various sites in the body, and I'll come back to that later, which are there to repair the damage. When cells or tissues have been destroyed, along come the stem cells and recreate new healthy tissue. But our stem cells get lazier with age, and after a while, they are not mobilized quite as effectively as they were. So this is another problem that we have. Now, all of these different processes, all of them, are adversely affected by inflammation, type B malnutrition, dysbiosis, and glycemic mismatch. And these are the problems caused by the modern ultra-processed diet. And these are the problems that we can actually address with Balance Oil, Extend, and ZinoBiotic. So we're on top of that. We're all over that. But the problem is that the tools I've just mentioned aren't quite the right ones to remove these unnecessary senescent cells, and they're not the right tools either to dislodge the stem cells that we need from their storage sites so that they can move into the rest of the body and rebuild the cell populations in those aging tissues. So what are senescent cells exactly? Well, these are aged cells. They have come to the end of their useful working life. And as I said before, they didn't, for whatever reason, succeed in terminating themselves. Instead, they linger on. And as I said, they're using resources, so they're a metabolic drain. They're not functioning. They're not contributing to the overall functionality of the tissue or the organ in which they are located. And just as bad, I mean, perhaps in some ways, it's even more of a problem. They secrete a range of messenger compounds, which is known as the SASP, which is the senescence-associated secretory profile. And all of these inflammatory factors that they're producing cause local damage to the tissue around them. They can actually drive local cells, which are still viable, into either dying or becoming senescent themselves. And these inflammatory factors have been shown to be able to accelerate the growth of tumors. So it's obviously not a good idea to accumulate too many of these senescent cells in your tissues. And if you do, and if they continue to accumulate and you don't do anything concrete about them, they will eventually culminate in the failure of that tissue, the failure of that organ, clinical symptoms, disease, and they will contribute to death. So let's try and remove them. And as I said, that is the fervent wish of the pharmaceutical industry. They're all over this at the moment. And there is, in fact, a lot of evidence that if you can remove these senescent cells selectively without damaging healthy tissues, you do get astonishingly positive results. So I'll talk about the preclinical results first, because it's always easier to work with mice than with men. I'm not leaving women out, it's just a phrase. And what these agents have been shown to achieve is that you can delay the development of many of the symptoms of old age. You can prevent the frailty from developing if the mice or the rats, some experiments have been done in rats also, have already become old and frail. You can see a restoration of function, a kind of rejuvenation. These agents have been shown to be very helpful indeed in the management of various cancers and in cardiovascular disease, neuropsychiatric conditions, liver disease, kidney disease, musculoskeletal, the list goes on and on and on. In other words, by selectively removing these senescent cells, you are expanding into a proliferation of therapeutic benefits. It is, in very real sense, a reversal of the large part of the aging process. And really interesting to me is that what you find in these rodents as they get older, they become more forgetful, they become less able to learn new tasks, for example, how to negotiate an unfamiliar maze. If you treat them with senolytic drugs to remove the senescent cells in the central nervous system, their coordination gets better, their memory gets better, their ability to learn gets considerably better as well. So it's like a rejuvenation of the entire brain and central nervous system. So does that extend into the world of clinical medicine? Well, it looks very much as if it does. The early pilot studies that we've seen reported so far show that, first of all, you can remove senescent cells. You can remove them from the tissues without causing collateral damage. And when you do that, you see reduced inflammatory markers in those tissues, which is always a good sign. And this is where it starts to getting really interesting, because you're now talking about real world experiential data. These elderly and frail subjects who receive these treatments show reduced frailty. They become more physically robust, more resilient, they have more energy. It's pretty fundamental stuff. And that has led to huge investments in this area, with the pharmaceutical companies pouring millions and millions and millions of pounds, dollars, yen, renminbi, if you will, into all of these clinical conditions: diabetes, pulmonary fibrosis, Alzheimer's disease, osteoarthritis, osteoporosis, eye diseases, and a whole range of others. This is a kind of a gold rush that's going on at the moment. So what are the candidate compounds for senolysis? This is what the pharmaceutical industry has given us, and dasatinib, navitoclax, galvanomycin, digoxin, wabane, other. Now, the first two are very specific. They were sort of developed to do this sort of thing. Particularly galvanomycin is interesting because, as the name implies, it actually comes over from an area that you'd think of as being antimicrobial, and digoxin and wabane are actually very old-fashioned cardiac drugs. So there's seems to be a very interesting toolbox, pharmaceutical toolbox, which you can use in different ways to knock out different populations of senescent cells. Other drugs are being repurposed as well. I think this is a very interesting area. I'm keeping an eye on it, and it's been an inspiration for the work that we're doing. Vaccines, lots of vaccines. Well, vaccines are very controversial at the moment, being pushed by drug companies with terrible criminal records, and who are now actively suppressing debate and the development of natural alternatives to the treatment, for example, of COVID and other infections as well. And then nanoparticles, nanoscience comes in here, and if you can get the right nanoparticles and fill them full of very specific toxins and target the nanoparticles to senescent cells, and there's ways of doing that, you could theoretically deliver these very toxic substances in minute doses exactly to the senescent cells and knock them out. And the early pilot work, preclinical work, says that you can indeed do that. But where it gets interesting, or at least where it gets interesting to me, is when we move over into the world of natural compounds, because it turns out that there are many, many phytonutrients which have this same ability. Now, most of these are polyphenols. So quercetin, which you can get from various plant sources, including strawberries, quercetin, typically from apples and onions, curcumin, I'm sure you've heard of that, that's from turmeric, luteolin from a variety of plant sources. And then, as well as the polyphenols, you have at least one alkaloid, which is piperlongumine, which is coming from one of the pepper-related species. And there's a few others that are just floating around and being identified as candidate compounds as well. So this was one of the areas where we focused. And then we also wanted to look at stem cells. And at this point, I have to admit to you that what we're conducting is a huge experiment. And if it was a drug that we were developing, I wouldn't even dream of launching anything like this. But what we are doing is launching natural compounds, formulations consisting entirely of natural compounds with phenomenal safety records, because we have been designed to consume these compounds. Our bodies know how to deal with them. We don't have to worry about combining them. And my feeling was, and this is where we've gone further than any drug company has and any other supplement company has, that if we could develop a way of knocking out the senescent cells with polyphenols, could we go one better and add a second component, which would move stem cells from their storage sites, get them into the circulation, and get them to go to those tissues where the senescent cells had been selectively removed, so the tissues could be repopulated, restructured, and returned to new, or at least as new as we could possibly get. And the answer is no, we're not forgetting the stem cells, but it's not an easy target. Stem cell function is extremely complicated. They have to be released, they have to be activated, and storage and release is a bit of an issue here, because the major long-term store for these stem cells which are, the body's own repair kits, if you like, is in the bone marrow, and particularly in the bone marrow of the long bones, for example, of the legs, and to a lesser extent, the arms. And the problem is that as we get older, they get lazier, they get more reluctant to leave their bunkers. And so even when you need them, they're not necessarily going to do the right job. They won't leave the bunker in sufficient numbers to allow the healing to take place, which is one of the reasons why when we're young and we get involved in a physical accident, you mend fairly quickly, whereas when you get older, that process of repair is slowed down. And so what we needed to do was to find a way to dislodge these stem cells from their long sleep in the marrow of the long bones and persuade them to move into the circulation and prime them in order so that they could get into the blood vessels and track, which is what they do anyway, to the sites of the tissue damage and repopulate those tissues. It turns out we could do that too. And this is where the fucoidans come in. And some of you have heard me talk about these before. They're antiartesans. They're very slippery compounds. When they get into the bone marrow, they will actually dislodge the stem of the stem cells so they can move into the circulation, become activated, and start to get involved in the repair process that I was referring to earlier. So there's good references for this. There's good evidence. We know that the fucoidans can do this. There is some evidence from Japan, and I will say this is very preliminary. This is clinical evidence, which suggests that the fucoidans can indeed, by releasing stem cells, improve the repair of certain types of tissues, for example, the re-anchoring of teeth in periodontal disease, and other indications for stem cell release of this sort. Osteoporosis seems to be an area where there is some evidence emerging in the reduction of toxicity of chemotherapy, and in vascular and eye diseases. So all these numbers in red in all of the slides refer to scientific references, which you will find in the text boxes attached to these slides if anyone wants to investigate the original research. Now, this is something else that fucoidans do. It has nothing to do with stem cell release at all. It's a similar mechanism, but it's being translated in a very different way. Biofilm, why should that worry you? Why should that be relevant at all? Well, biofilm is, one example of that would be the plaque that forms on your teeth overnight, and if left uncleaned, becomes tartar, mineralized plaque, which contributes to gum disease and is a very significant cause of the loss of teeth. The fucoidans have this ability to inhibit the formation of biofilm. And in that sense, they're extremely good for oral health as well. For those of you who've been to the dentist who've used plaque disclosing tablets, you chew on the tablet, and even after you've brushed your teeth, you'll see to your alarm that this ingredient in the tablet will stain your teeth red or sometimes blue because it's attaching to the plaque that's on your teeth that the toothbrushing did not remove. If you're eating fucoidans, the next time you do this test, you will see that there's very little stain there at all because the biofilm is inhibited by the fucoidans and it acts synergistically with toothbrushing. So this is a huge benefit for oral health. So spring clean with ZinoGene, this is a way of repopulating your cells, replacing the old with the new. We're not entirely sure yet whether this is something you can do frequently, and if so, how frequently? I'm thinking of 3 or 4 times a year, a short 2-week course. You don't need more of it than that. What are we starting to hear back from our human guinea pigs? And can I just say, I was one of the very first guinea pigs. I wouldn't ask anyone to go down this road unless I'd explored it thoroughly myself, as well as researching it in the literature, obviously. What we're seeing is improved joint function, which doesn't surprise me because the curcuminoids that we're using in ZinoGene, and we're using very high bioavailability ones, and we know for sure that we're reaching levels in the tissues where senolysis takes place. But some of the best research literature indicates that the curcuminoids have the ability, specifically, preferentially, to target senescent cells in cartilage, whether it's in the intravertebral discs of your spine or in the joints, in the cartilage and other joints. So we're hearing quite a lot of reports of people who are saying, well, my knees and my hips and my back I don't have pain anymore. I have flexibility, which I haven't had for a long time. I've seen a kind of articular rejuvenation. The other thing that we're seeing quite a lot of reports on, and frankly, I didn't expect to see this so soon, is that people are saying that their original hair color is returning. So oldsters like me, we have a lot of gray hair. In my more elderly population, a lot of people are saying, well, my original hair color is coming back. And I've actually noticed a bit of that myself. The idea of targeting senescent cells eventually translates into a lot of clinical benefits. And I actually have written out a list of 2 or 3 pages of the types of benefits that I might expect to see. And to be honest, the recoloring of hair was right at the end of that list at the bottom of page 3, but it seems to be the one that's happening rather more quickly. I don't know if it happens in every case, but a lot of people are reporting this. So think of ZinoGene like this. It's an infrequent, intensive cleaning course that you might wish to explore. And so far, it's working out pretty well. The other topic that I want to address, and I don't want to run over because I want to leave time for questions, is this concept of dysbiosis and restoring the microbiome. Now, this is something that has been really brought into the foreground by what we call dietary shift. Our introduction of industrial food into the human food chain, which has happened increasingly since about 1950, has really damaged the national diet. I could say the international diet, to the point where IMHE, which is the Institute of Health Metrics and Evaluation, who crunch all the large data, they say unequivocally that poor diet, dysnutrition, is now the single most important cause of early death, which means avoidable death worldwide. So it's official. Our modern foods, the modern ultra-processed foods, are now killing more of us than tobacco or alcohol or recreational drugs. Our food has become extremely toxic. And one of the ways in which it's become extremely toxic is it has stripped out a lot of the fiber, specifically the prebiotic fiber, that was always present in our diets until as recently as, I would say, the very early 20th century. If you take these fibers out of the diet, you end up with dysbiosis. That is the wrong population of microbes in the large bowel. And that has now been associated with a hugely increased risk of a range of pathologies, which I'll go into in more detail. These fibers, which you find in cereals and fruits and vegetables, and I'll list some of them later, are vital nutrients, not for us, we can't digest them, but they are vital nutrients for the probiotic microbes that live in the large bowel. So this is a schematic representation of what's going on down there. And across the bottom of the slide, you can see 4 cells. They're basically epithelial, colonic epithelial cells, the cells that line the colon. And at the top, in the lumen of the gut, you see a group of microbes in green, and they are probiotic species. And the reason why they're there is they are saccharolytic, which means that they like to eat these fibers. And the fibers are present in the residuum of the food that enters the large bowel, which is in the lumen, so the microbes are there. And what they do is they break those fibers down, they're carbohydrates, but not the kinds you're familiar with, into short-chain fatty acids, so acetic, propionic, butyric. And those fatty acids have really interesting functions in our bodies. And I'll talk only about butyric acid, I think, because that's probably the most important. Butyric acid is a very, very potent anti-inflammatory, and it is also very good at killing cancer cells. So this is a representation of a very healthy state of affairs. This is someone who's eating lots of prebiotic fiber. They've got lots of these green gram-positive bacteria. The gram-positive bacteria are breaking the fiber down into butyric acid, and that is why there is no inflammation in this colon, and there's no cancer cells. And this is how things used to be up until the beginning of the 20th century. Now, we have to go forward 100 years 2021, 2022, and now we're eating increasing amounts of ultra-processed foods, which are linked to all kinds of increased risks of illness and early death. And one of the reasons why they are so good at making us sick and killing us is that they do not contain sufficient prebiotic fiber. And if you're not eating enough of these prebiotic fibers, then the green gram-positive probiotic bacteria start to starve and their numbers decline, and they are replaced by gram-negative microbes, and they're colored in red here. And the gram-negative microbes don't like to eat fiber. They actually like to eat mucin, which is the layer of mucus. It's a that lies over the colonocytes and protects them. So they erode it, they break it down, and those gram-negative bacteria come into direct contact, as you can see at the bottom of the slide, with our epithelial cells, the colonic epithelial cells. So two very bad things have happened. Firstly, the gram-positive microbes have diminished in number. They're no longer producing butyrate, the anti-inflammatory, so the cells are now exposed. But it's worse than that, much, much worse, because when the gram-negative cells, the red ones, come into direct contact with the cells that line the colon, they're gram-negative because they're coated in lipopolysaccharide. And that is highly pro-inflammatory. In fact, it's probably the most pro-inflammatory substance that we know. And so when these gram-negative, the red microbes, come into direct contact with the cells that line the large bowel, you get a huge problem with inflammation, chronic inflammation. So a lot of the epithelial cells die, and they start to separate, and you can see on the right and at the far left, the tight junctions between the cells start to open up. And now you're in real trouble because endotoxemia results. And that is when the lipopolysaccharide and other macromolecules that should be kept inside the bowel, you now have a leaky gut. They get through the lining, they get into the bloodstream, and they cause all kinds of damage in other tissues, in the blood system, in the liver, in the brain. This is a really seriously damaging pathogenic situation, and it's one that we want to avoid. And this is why we have so much IBS, so much IBD, one of the reasons why we have so much cancer and cardiovascular disease and neurodegenerative disease today. This is a very, very major nutritional and health issue. So what should we do? Well, we really want to restore a much more traditional form of microbiome, which we do by putting these prebiotic fibers back into the system. It's as simple as that. You don't need anti-inflammatory agents, you don't need steroids, you don't need any of those sorts of things. You just eat those food-derived fibers, which then are what the gram-positive green microbes need. They start to grow. And as they start to grow, they produce very selective toxins that kill off the gram-negative bacteria. Not all of them, but it brings them down to manageable levels. And because there's so much fewer of those really destructive gram-negative species, the mucosal layer builds up, the inflammation in the gut stops, the cells come back together, the tight junctions reform, you no longer have a leaky gut. And now these green bacteria, the probiotic species, if you're continuing to eat these prebiotic fibers, are once again producing butyrate. So now the conversation between the microbiome and the cells has moved away from being inflammatory and carcinogenic. It is now anti-inflammatory and cancer protective. So what are these prebiotic fibers? Well, for anyone who's listening who has a chemistry background, you can see that they are carbohydrates. So glucose and fructose moieties that are linked together, but they're linked together in a way which means that our digestive systems cannot break them down. So they pass through the small intestine intact. They're not broken down into glucose or fructose. They go straight into the bowel where they're metabolized to these fatty acids. So diabetics can eat these fibers without any kinds of problem. We use a small amount of fructose, fructooligosaccharides, and we only use a small amount because, as you can see here, it's a small molecule, which means that when the bacteria start to break it down, they do so very quickly, and it's a very rapid fermentation. This is actually a fermentation reaction, rather like the process that happens when you're fermenting beer or wine. And we use larger amounts of inulin, which is the same molecule, similar, but much, much longer, so the fermentation is slower. We add larger amounts again of this. This is a 1314 beta-glucan, and we derive this from oats. And we use larger amounts again of resistant starch, and we can derive this from green banana. And the reason why we mix them all up in the right proportions, and it's very important to get the right proportions, is that once this blend of fibers enters the large intestine, everything is moving. Everything inside the gut is moving. And so what happens is that as the contents move through the colon, it is the very short chain, rapidly fermenting molecules, the FOS, that starts to ferment first. And it starts this process of increasing the good guys, the gram-positive probiotic species, and removing the unwanted gram-negative microbes. And it starts here in the ascending colon, and then inulin takes over in the transverse colon. The 1314 beta-glucans from oats take up the job next, and then finally the resistant starch takes over. So it's like a relay race, if you like. And in this way, we affect this microbial or this microbiomal transfer from overwhelmingly gram-negative to overwhelmingly gram-positive and protective throughout the whole length of the large bowel. We're promoting the growth of some bacterial species that I'm sure you've heard of. So the lactobacilli and bifidobacteria in the large bowel are very similar to those that you'll find in, for example, live yogurts, kefir, kombucha, other fermented foods like that. But we are also supporting the growth of some other very, very important gram-positive probiotic species. So Faecalibacterium, Prausnitzii, Akkermansia, Mucinophila, and Roseberia intestinalis, and there's others. And what all these have in common is that they are all positively associated with good health, both in the gut and in general, and they all produce butyrate, this really all-important anti-inflammatory chemoprotective compound that is a very good idea to be producing inside the body. And ZinoBiotic ensures just that. How good is this for your health? Well, I'm not going to talk about ZinoBiotic, but I'll talk about fibers in general. And the best data that we have comes from a huge meta-analysis carried out on behalf of the WHO in 2019. And when they looked at all the numbers available to them, they were able to confirm that higher fiber intakes reduced early death by 30%, which is a hugely significant amount of protection. And you can break that down into a reduced risk of bowel and breast cancer, reduced heart attacks and strokes, but there's more data is coming out now as well, because it also shows that it reduces the risk of non-alcohol related fatty liver disease, which is a risk factor for liver cancer. And this has also now been implicated in the significant reduction of risk if you're eating more fiber of the neurodegenerative conditions. We knew that there was a connection with Parkinsonism. Recently, there's some very persuasive evidence emerging that shows that this type of diet is associated with a reduced risk of Alzheimer's as well. So these prebiotic fibers are really important to include in your diet, as important as any vitamin or trace element. And in fact, they should be recategorized, in my view, as vitamin-like compounds. How much of this stuff should you be eating? Well, the WHO said the minimum amount you need is about 30 grams a day, but if you eat more, you'll get more protection. There's a dose-related effect here. So the more fibers you eat, the more that you're protected. The kicker is that not enough people are eating even the minimum amount of fiber. 9 out of 10 people are not eating enough. The average intake is only half the WHO minimum recommended value. When you break it down further, out of that 15 grams, only a quarter of that is prebiotic fiber. So to extrapolate backwards from that, what this means is that the WHO is actually recommending you should be consuming as a minimum of 7 grams of mixed prebiotic fibers a day. And we've gone a little bit better than that. If you follow the recommended dose of ZinoBiotic, we're up at the range of about 10 to 12 grams of prebiotic fibers, which we have already seen from our very large network of consumers is extremely protective in a whole range of different conditions. there's a lot of other science that we have. I mean, I haven't touched on extend or balanced soil. I can talk about vitamin D briefly if you wish, but I know that there's only a limited amount of time available to me. And what I'd like to do is to throw the mic open for questions. And I'll answer as many of them as I possibly can.
So, ladies and gentlemen, we have an extraordinary chance to ask some questions from Dr. Paul Clayton. So, does anybody have any questions? Feel free to ask. We are dealing with Estonians, Paul, so they are a little bit shy, I know.
Oh, no, Estonians
Hey.
are some of my favorite people.
Hi, can you hear me all right?
Yes.
Yes, yes.
Okay, this is a question from Saaremaa team. So basically, thank you very much for this fantastic presentation of the products. With the ZinoGene, is there a sort of recommended age band that people can or should use ZinoGene? Specifically, is there like minimum age band where it's might be recommended? Thank you.
Well, I don't think teenagers need ZinoGene, and I'm not sure that you need it in your 20s, 30s, and 40s. I think that based on the totality of the evidence that we have available to us, is that once you start moving into the second half of your first century, then you're going to start to be accumulating senescent cells. So I would say with a fair degree of confidence that most people in their 60s and older will experience some benefit. And I think that we could probably include some people in their 50s as well. Now, you, I'm sure, are aware of the fact that not everybody ages at the same time or at the same rate, and so or as successfully as others. So some people will reach 50 or 60 and still be very physically fit, cognitively fit and everything, and it's clear that they're doing something right and they're not aging rapidly. But we know other people who, by the time they move into their 50s, are already looking and moving and thinking like old people and do have a range of pathologies. So it's really a matter of judgment. If you want to have 50 as a kind of threshold, that's fine. ZinoGene may well have an effect. It won't do any harm, and it's worth trying. But if you're talking about people who are a little bit older than that and perhaps are starting to develop lifestyle-related problems and issues, you're more likely to see a benefit there.
Thank you. There was actually one more question from here, is that whether there is any evidence that the same mechanics and compounds could have a positive influence in the treatment of Alzheimer's.
Oh, right. I think they have a role to play. But if you look at the pathoetiology of Alzheimer's, it's really, really complex. And I sort of hinted at that when I talked about the relationship of the microbiome to neurodegenerative diseases, including Alzheimer's. For anyone who's interested, if you go to my blog site, which is drpaulclayton.eu, and but I'll just put down the address here. There are a couple of posts on this which talk about the microbiome and Parkinsonism and Alzheimer's. There is a very, very good clinical scientist called Professor Dale Bredesen, who is a friend of mine. He's based at UCLA, and he has been looking at this issue in great detail. He believes, and I think I agree with him, that there are different types of mechanisms which can culminate in Alzheimer's. And people who've gotten to Alzheimer's through these different routes require slightly different interventions. But what he has been able to show is that in a group of patients who were starting to develop Alzheimer's and had been clinically diagnosed and the diagnosis had been substantiated, when he put his program into place, the early signs disappeared. and these people were restored to normal functioning. For those of you who are interested, a lot of what he did is already incorporated in our health protocol. And I'd gotten to that through a slightly different route. But then it turned out that what he was doing and what I was doing, there was a lot of convergence. And I think you can add probably courses of ZinoGene to that as well. Now, I cannot talk directly about Alzheimer's cases. Dale's work shows that the early beginnings of Alzheimer's can be reversed. And this is medical heresy, but his papers have been published now, and the literature is really good. I've seen a couple of cases now where patients who had Parkinsonism, which had been clinically diagnosed by the experts, by really senior people, went on to these types of intensive nutritional programs and have been stabilized. And in fact, their symptoms have gotten less over the years, so much so that some of the experts who made the initial diagnoses have now recanted and said, oh, well, this is unprecedented. We've never seen these cases get better before. So maybe I got the first diagnosis wrong. Now, it's not easy for a very senior and well-known consultant to admit that he or she might have made a mistake. I don't think they did. I'm pretty certain the diagnosis was correct. All the symptoms matched. But I think what we have to now start to consider is the very real possibility that where the pharmaceutical industry has failed, we can succeed by reestablishing what we call pre-transitional nutrition. It seems to be able to do a lot of other exciting things as well, which I don't think we've got time to go into. But as I said, if you go to my blog, you'll see very short, very easy to read articles. They're all heavily referenced, and they'll tell far more of the story than I could live.
Brilliant. There was another question here in the chat. What kind of products are you using yourself, and how often?
Well, I use the health protocol. I mean, because I believe in it. And a lot of my medical colleagues are now doing exactly the same thing. And every now and then, maybe once or twice a year, I'll take a 2-week course of ZinoGene.
Okay.
And but you know, I mean, I do other things as well, and I recommend you all do as well. For example, if you smoke, I would suggest you don't. If you live a very sedentary lifestyle, I'd suggest it would be a good idea to start taking a little bit of exercise. If you live a life that's extraordinarily stressful, I would advise you to explore stress reduction techniques. I mean, you know, the supplements are great. These pharmaconutritional tools are incredibly potent, but I don't want to leave you thinking that that's all there is. What we're trying to encourage people to do is to examine and to review their lives and improve, make general improvements. Our ambition, our target is to try to help people to be better, to be more fulfilled, to be more autonomous. And so it's a lifestyle thing. The nutritional and pharmaconutritional tools are a part of that, but they're not all of it.
Yes. One question, because I was listening myself and a lecture about microbiome, and they were also talking that you would benefit if you also, next to using prebiotics, you still use some probiotics. So how important would that be, or is it?
To be honest, I don't think it is. There's a huge literature on probiotics, and of course it's been taken up by the food industry, who offer us probiotic products. But the evidence that the probiotics have very much of an impact is actually disappointing. And that's one of the reasons why, for example, EFSA hasn't yet agreed to a single probiotic claim. When you think about it, it sort of makes sense, because no matter how many colony-forming units you're swallowing in a capsule or in a pot of yogurt, the numbers are really very, very small indeed compared to the numbers of microbes that already are living inside you. And the problem is that these microbes that you're eating in the products have been living a very insulated lifestyle. They've been bred under ideal conditions. They're soft, if you like. They're, you know, new recruits. The bugs that are living in your gut, they're like battle-hardened soldiers. They know the terrain. They're used to living in there. That's their environment. They know it. So when these new guys come in, they don't last. They get wiped out pretty quickly. And all the studies that I've looked at say that, well, yeah, you can take a probiotic. It might have a slight effect, but the day you stop taking it, they're gone. There's not a trace of them left behind. So the impact is relatively small. It's very temporary, very transient. If you want to change the overall population around and configure it in a more health promoting way, send in the supplies, because you already have small numbers of your own probiotics in the gut. Not many, because you're not eating very much fiber, but they're clinging on and they know the local terrain. They're battle hardened. Send in the supplies that they need and they will multiply dramatically by thousands and thousands and thousands of times, and then they will win the war for you. It's a far more systemic and systematic approach. I have not seen any convincing case where adding probiotics to the prebiotic has achieved very much.
Brilliant, brilliant. Thank you so much. And guys, if you were just as fascinated as I was about this talk, then do get Dr. Paul Clayton's latest book that you can also buy from the same webpage, drpaulclayton.eu. And you can spend your whole day with Dr. Clayton. And of course, our Go Core and all the other videos that we have online, and do enjoy those as well. But Paul, we are so grateful to have you. We're so happy to have you as the leader of our scientific board. And it's always as big of a pleasure to have you talk to us. And of course, develop these unimaginably great products. We're so grateful for those. Thank you.
I just hope that once this coronavirus nonsense has passed over, that it'll be possible for me to return to Estonia. I've had I really like Estonia, and as soon as the travel restrictions are eased, I'll be back.
We'd love to have you. Thank you so much, Paul, and have a great day over there.
Thank you.